up this unit. So now we're talking about absorption of fats. So after the emulsification droplets are turned into micelles due to the bile salts and phospholipids, they are absorbed by the apical side of the enterocytes. And there they are transported to the smooth ER of the cell, where it is actually turned back from the micelle into triglycerides, and then it's also combined with phospholipids as well as cholesterol to form chylomicrons. And additionally, they will also attach proteins onto the chylomicrons to make lipoproteins. So the proteins that are on the chylomicron are called apoproteins, and they're basically like a badge number to help identify this fat droplet and where it should go in the body. So once these micelles are turned into triglycerides and then packaged into chylomicrons and then eventually lipoproteins, they exit the cell via exocytosis on the basolateral side, and they enter the lacteal and lymphatic system, and they will go into the circulatory system, blood system, via the thoracic duct. Once the chylomicrons are in the blood system, then they travel to the cells all over the body, and they bind to endothelial cells. And on the membrane of these endothelial cells, there is an enzyme called lipoprotein lipase, which breaks down the triglycerides in the chylomicrons. And this allows the cell to quickly absorb the fatty acids. Now, there's also, the cells can also resynthesize the triglycerides inside and store them for later use if the energy is high. But if the energy is low, then it will just break it down into fatty acids for use. Additionally, fatty acids are transported in the bloodstream by albumin, and albumin, side note, is what contributes to the oncotic pressure. Now, there's two types of lipoproteins. So there's high density, low density. So it's actually counterintuitive. Low density is the highest concentration of fats. It's transferred to adipose cells. High density is actually lower concentration of fat, and it's transferred to the liver for recycling and excretion.